Okay, the question here is about throwing an ordinary dice on which you can score 1, 2, 3, 4, 5 or 6. The dice is thrown 3 times, and the question says, what's the probability that the total score is 18? Now, to get a total score of 18 when you throw 3 dice, or 1 dice 3 times, it makes no difference. The only way that that's going to happen is if you get a 6, and then you get a 6, and then you get another 6. In other words, you get 3 sixes. Now, the probability of that happening, and remember, for probability, we multiply when we see the word and. All we're going to do is multiply together the probability of getting a 6 by the probability of getting a 6 by the probability of getting a 6. Each of those throws, remember, is independent of any other throw. So the probability of getting a 6 is a 6. Probability of getting 6 again is a 6. Probability of getting 6 again is also a 6. And if I multiply those all together, well, just 1 times 1 times 1 is 1. 6 times 6 times 6 is actually 216. So the probability of getting a total score of 18 is 1/216. Obviously, if it hadn't been 18, if it had been 17 or 16 or something else, it would have been more complicated, and I would have had to look at other ways of doing it. Okay, let's have a look at the second part then, because it says, what's the probability that the score on the third throw is exactly double the total of the scores on the first 2 throws? Now, I don't like this question. It's quite complicated. So I am going to make a little table and start thinking about what possible things could happen. So let's have a look at what the first throw could be. And then let's have a look at what the second throw could be. And then I'm going to look at the total. And then I'm going to look at what my third throw would have to be. Okay, so let's say, start simple. Start with the smallest. Let's say we got a 1 with our first throw and we got a 1 with our second throw. The total score then of the first 2 throws is 1 plus 1, which is 2. And if I want the score on my third throw to be exactly double that, then the score on my third throw would have to be a 4. Now, the probability of that happening is the probability of getting a 1, and the probability of getting a 1 on my second throw, and the probability of getting a 4 on my third throw. And basically, the probability of that is just a 6. The probability of getting that is also a 6. And the probability of getting a 4 there is also a 6. So the probability of getting a 1, then a 1, and then a 4 is actually just a 6 times a 6 times a 6 again, same as up here, which is just 1/216. Okay, let's see what else. So that's one of the things that could happen. Let's say next possibility is that I get a 1, and then I get a 2 with my second throw. So my total score there is 3. Now, if I got a total score of 3 with my first 2 dice, my third throw would have to be a 6. Again, the probability of that happening, a 1, and then a 2, and then a 6, well, it's going to be exactly the same again. A 6 times a 6 times a 6, again, 1/216. Okay, what I've realized is my third throw cannot possibly be bigger than a 6. I can't get more than a 6 with my third throw because the dice only go up to a 6. I can't get more than a 6 on one throw of a dice. So actually, the biggest possible, the only thing that I could possibly have is a 2 on that first one, a 1 on that second one, giving a total of 3, and this being a 6 again. There's absolutely nothing else that could happen here for the criteria for the question to actually work. So the probability of getting a 2, then a 1, and then a 6, still a 6 times a 6 times a 6, which is still 1/216. So there's 3 different ways that this could happen, by getting a 1, then a 1, then a 4, or a 1, then a 2, then a 6, or a 2, a 1, and a 6. And each of those have a probability of 1/216. Now, it's an either-or situation. Either that happens, or that happens, or that happens. In other words, I'm going to add together these 3 probabilities. So 1/216 plus 1/216 plus 1/216, which is just 3/216. So my final probability there is 3/216. Oh, actually, that simplifies to 1/72, I've just realized.